So the intuitive notions of infinite limits, we investigate the limit at a point C of irrational functions of the form f of x over g of x, where f and g are polynomial functions, with f of c is not equal to 0, but the g of c is equal to 0. So note, the theorem 3 does not cover this because it assumes that the denominator is non-zero at c. So we can use also the indeterminate form 0 over 0 here. So example, the limit of 1 over x squared as x approaches 0. So by direct substitution with 0 in the denominator, so 0 squared is equal to 0. So 1 over 0 is undefined, or the f of c is undefined. Now, the using the rationalizing or factoring, we cannot determine the limit of the value because there is nothing to factor here and there is nothing to rationalize here. So f of x is equal to 1 over x squared, while the c is equal to 0. So now we will just create table of values to determine the limit of the function. So x is equal to negative 0.9, negative 0.5, negative 0.1, negative 0.01, negative 0.001, and negative 0.0001 in the left side with its equivalent of f of x here. Notice that as x approaches to 0 in the left side, the value of the f of x approaches to e and to infinity. So this is positive infinity. So therefore the limit in the left side table is equal to the positive infinity. Same goes here at the right side. So we put values of x here in descending order: 0.9, 0.5, 0.1, 0.01, 0.001, and 0.0001. So this is approaching to the value of 0, while the f of x is also approaching to the values of infinity or positive infinity. So therefore, for this case, since the limit in the left side and the limit on the right side are both positive infinity, so the limit of the function is equal to positive infinity. So this is limit of 1 over x squared as x approaches 0 is equal to positive infinity. You can see that in the graph, both in the left side and the right side approaching 0 or approaching to infinity, both in the left side and the right side. Another example here, limit of negative 1 over x squared as x approaches 0. So we cannot use factoring or rationalizing here. The denominator is equal to 0 squared or 0. It makes the function undefined. So to get the true limit of the function, we will use the table of values to determine the limit of the function. So here at the left side, as x approaches 0, the function approaches to negative infinity. So imagine this one, to negative 100 million. And then same goes here at the right side. As x approaches 0, the value of the f of x here approaches to negative infinity. So therefore, since the limit of the left side and the right side are equal to negative infinity, so we could conclude that the limit of the function is equal to negative 1, negative infinity. You can see that in our graph. Another one, limit of 1 over x as x approaches 0. So 1 over 0 is undefined. So we will just use the table of values or graph of the function. Now, here we use the graph of the function. We can see that as our graph approaching to the value of c, which is equal to 0, the value of the f of x or the y approaches to negative infinity. While here at the right side, as our graph approaching to 0, x is equal to 0, the value of f of x or the y approaching to the positive infinity. Therefore, since our limit in the left side is negative infinity while at the right side is positive infinity, we can deduce that our limit of the function is t in e or does not exist since the left side and the right side limits are not equal. So that's all for our topic for today. Thank you for listening. I hope you have learned something today. God bless and study for your upcoming preliminary examination. Bye bye.